My time now shows 2 o'clock. So we will start. Welcome to this webinar hosted by the ROADVIEW project. It's about standardization and the regulatory framework. My name is Fredrik Varg. I will be your host today together with Aaron Aksoy, who is the coordinator of the project. Maybe you can wave, Aaron, so they see who you are.
Hello, everyone. Very welcome.
Before we start, we have some housekeeping rules. The event is being recorded and it will be posted publicly. So if something appears that you don't want to be on the public recording, please contact Mario, who is organizing this, at the email address that you can see here after the webinar, and he will make sure it's edited out. You cannot speak, but you have 2 chat boxes, one called chat, where you can write if you have technical issues, and one Q&A box. So if you have questions regarding the contents of the speeches, write in the Q&A box. After each talk, we will have a short Q&A if there is time. Take a few questions. If there's more, we will leave it to the end of the webinar. In general, the ROADVIEW webinar series, it's a series of webinars on connected and cooperative automated mobility. We try to invite experts in different fields and hold one webinar about every 6 months. The scope are a bit different. We have different topics, of course, but in general, we have standardization and regulation could be a topic like today. We also want to raise awareness about CCAM solutions. We want to present the findings in the ROADVIEW project, of course, discuss technical challenges in this area, also raise awareness about the CCAM partnerships and present market applications of ROADVIEW technology. So that's the reason we are holding these webinars. And if you want to stay in the loop and be alerted next time there's the webinar, you can subscribe to our newsletter. There will be a link in the chat. Today's webinar is called Standardization and the Regulatory Framework. And we have a few presentations. The first one will be from Fredrik Sandblom, who will talk about safety of automated driving systems, standardization, best practices, and regulatory challenges. I will present everyone a bit deeper in a minute. After that, there will be a shorter session from myself, talking a bit about relevant standards in the context of ROADVIEW. And the last block will be Isabel and Michael, who will talk a bit. They are both experts in different standardization committees, and they will talk a little bit about their work and experiences from that. And in the end, we have a discussion and we will take any questions that we could not take after each presentation. So the first speaker, Fredrik Sandblom, he is a technology expert and system architect at Sensact. Sensact is a subsidiary of Volvo Cars, focusing on software for automated driving system and advanced driver assistance systems. But ADS is Fredrik's main interest and expert area. He has also a lot of experience in standardization, and that will be the basis of his talk today. He's a national expert in the development of the ISO TS 5083, which is currently being developed and hopefully being published later this year. And the domains of interest are ADS standardization and regulation, and traffic safety in general, and verification and validation of ADS safety claims in particular. Then we have myself. I'm a senior researcher in the unit Defendable Transport Systems at RISE, Research Institutes of Sweden. My domains of interest are safety and security for connected automated vehicles, and in particular, safety assurance and safety verification methods. Isabelle is a research engineer at Canon Research Center France, Isabelle Morvan. She is also an expert contributor to the standardization of cooperative ITS in the ETSI ITS Technical Committee. And her main interests are wireless communication in this context, CCAM. And then we have Michael Drexler, who is a research fellow at the Hardware in the Loop laboratory of Charisma Institute of Automated Driving. He has an MSc in automotive engineering from Federal University of Santa Catarina and Technical University of Ingolstadt. I took it in English. The domains of interest are autonomous vehicles and AV safety and security. So let's see, do we have any issues yet? Otherwise, I will leave the floor to Fredrik Sandblom. While he's connecting, you can see all the partners of the ROADVIEW project.
I like that you added yet. Do we have any issues yet? Should I start sharing then?
Yeah, you can start sharing now.
Then I will do that. And you please confirm if you can see my screen now.
I can see your screen at least. If anyone cannot, then write in the chat.
Excellent. Sorry, I am recovering from a cold, so my voice is not as stable as it usually is, but I hope you can hear what I'm saying. Otherwise, write it in the chat or something so that someone can react to it. So I call this Safety of Automated Driving Systems, Standardization Best Practices and Regulatory Challenges. And I realized when making the presentation that 15 minutes is short to cover all of this. So I'm trying to outline a red thread. And I'm hoping for an interesting discussion afterwards. And you're always, of course, free to contact me if you have questions that we don't have time for today. The objective with the presentation is to give a brief introduction to ISO TS 5083. It's safety for automated driving systems, and it's not published yet, so I cannot show any extracts from it, but I can tell you a little bit on what you can expect. I want to clarify what I believe are some relevant characteristics of the safety of automated driving systems that I think can come in handy to discuss, and especially to connect them to the third objective, which is to explain why it's quite difficult to formulate efficient regulations when the purpose is to ensure safety or safe operation. And of course, some time for questions. So standards, I'm assuming that people here have a wide background, so anyone who's an expert in any particular slide will find it maybe not to the detail level. But I think for those not familiar with standards, you can think of them as a formula that describes the best way of doing something. That's how ISO presents their purpose. And we have experts here from ETSI, and there are a wide range of entities such as corporations or regulatory bodies or standardizations organizations that can develop these standards. Sorry. I have been working with standardization since 2010 when I was working with ADAS systems in TC204. And now I'm working as a Swedish national expert in the development of this ISO TS 5083. Safety for automated driving systems, design, verification, and validation. And this is not work that is created from thin air. There has been development all around the world in many areas. The TR 4804 should be mentioned specifically as one of the source documents that initiated this work. And the idea is to provide a guidance. This is an application-specific standard. There are safety principles that are perceived to be generally agreed upon, and we focus on L3 and L4 driving according to the J3016 definition, which also has an ISO name with a POS issue 22736. And it covers road vehicles but excludes motorcycles. So it is an application-specific document. And what does that mean? It means that this is where you start. So there are many standards that you can apply for many different purposes, but the idea is that when you start developing an automated driving system, you can pick up TS 5083 and you can start reading it, and then you will find that it will direct you to go to other places as well. But it's good. It provides a connection and guidance on how to use those other standards efficiently for this specific purpose. So it adds structure to the task and it covers some gaps. And I will come a little bit more to them on the next slide. Technical specifications can have requirements, and we do. So it means that you can argue compliance to TS 5083. But a technical specification, if you're not familiar with that, in ISO you can have different publications. You can have reports, technical specifications, and the international standards. And the higher up you go in that hierarchy, the more mature the technology has to be, because you do revisions more rarely and they're supposed to be valid for a longer time. So the TS is quite appropriate for automated driving systems because we can do rapid update cycles, and the development cycle is shorter than for an international standard. And you will find publications, a publication of this one after the summer. There is a date, but I don't know it in my head. Should also be mentioned that ISO prioritize consensus when we discuss, and it means that the level of detail can vary over clauses. And you can see that sometimes if you believe that something is very challenging, or it can be done in very many ways, maybe it's hard to write down easy to understand guidance on what can describe all of that. So then it can become quite shallow. And then in other sections, it can be very detailed. And that could be either because the society at large agrees that this is exactly how to do it, or because some have a good suggestion and others did not have an opinion. So you have to know that when you read an ISO document. And of course, the more mature and refined they are, the more even they are in this aspect. And I point here at three very relevant standards: the ISO 26262, 21448 at SOTIF, and the cybersecurity 21434, because they are directly referenced and form, you could argue, the basis of the previously published work that relates to safety of automated driving. The general structure, you recognize the V model. I want to highlight just some aspects, and it's that the feature and operational design domain and the risk acceptance criteria has to be seen as one entity. They are developed or described jointly. And it's important because the risk acceptance criteria is what has to be valid when you are doing what you intend to do. So that's the ADS feature and its intended usage, and where you are doing it. So it's the operational design domain. And that provides a good input for the verification and validation part, where the operational design domain becomes your criteria for completeness, essentially. That's how I see it, and I think it's a useful model. And then we also say that the requirements, the safety requirements, are distributed onto the ADS and external to the ADS. And I think this is an elegant way of making sure that assumptions that you're making when designing your ADS becomes visible in your safety case structure. And it can be, some of the informative examples are using it differently, but I encourage you to have a look at the different informative examples and see how you can use it. And this should not be considered to be something related to what is on board or off board, but it relates to having completeness on vehicle level with respect to those safety requirements. The scope, these are some key takeaways. The scope doesn't exclude any source of harm. It means that if you read other standards, you can find that here we are focusing on hazards as a function of, and then there are limitations. But the idea here is to be able to argue or reason around how will this perform in total, including all aspects or all sources of harm. And I think that is a very important contribution, because it leaves out gaps that exist if you apply other standards. I mentioned the important relation between the feature, the operational design domain, and the risk acceptance criteria. And we should realize that if we change one, we have to change the others, or at least update the others, because it's not for sure that you can isolate them, or it's for sure that you can't. And this allocation of of safety requirements to the ADS or external to the ADS, I also think is an important component in this document that I think you should have a look at. It facilitates the ADS design. but it has nothing to do with onboard and offboard elements. And I'm saying this many times because that has been a source of confusion for a long time. But just briefly consider the example when you have an automated driving system that is driving cars in parking garages. And then you can have sensors inside the garage to do this. And obviously the sensor is a part of the automated driving system, even though it's allocated off board or not on the vehicle at hand, just so that is clear. And the TS is based on arguing safety by design through requirement refinement. And I want to say something about safe automated driving. And you have seen probably the definition of safety from 26262. It's the absence of unreasonable risk. And when I approach this, I read this because of my estimation theory background and traffic safety. I would say that this means that the risk of harm is reasonably low. But some may focus on the unreasonable part and say that this means that there is no risk for unreasonable harm. So if it was foreseeable or easy to prevent, then we cannot accept it. And those two interpretations are not the only ones, and they are not at conflict either, because they both capture relevant aspects of safety, but they serve as examples of how safety can be interpreted quite differently. And I find it personally that understanding when you're talking to someone what their definition of safety is important to clarify first, so you know you're talking about the same thing. And here we can move over the whole range of safety being mainly related to the risk of harm, all the way to we would find it negligent if an accident was caused by not doing something particular. And then we typically associate that as well to safety, although it may be a subjective judgment rather than a clarified causality. On safe automated driving, it is important to know that observing the absence of injuries is called the billion miles problem. And if you try to observe that and see that it's low enough to argue that you are better than a human. And this means that observing the vehicle level behavior can only be used to prove that you are not safe. And even that could be tricky sometimes. But if you see obvious safety issues, then maybe you can say that this is not a safe vehicle or a safe automated driving system. But not seeing it doesn't mean that it becomes safe. We usually say that if we wanted to test the Viking ship to this level, all of them ever built would be still in the testing phase. So it's very hard to do this, and that's not how we should do it. So therefore, it becomes very relevant to refine your requirements onto components and things that you can observe that occur with a higher frequency, so that you can back up your safety claim with actual data that doesn't require driving for an insane amount of time. And again, this is not only saying that the industry shouldn't do it because it takes a long time, but it becomes infeasible because then you cannot update the system even if you had that amount of data. And it's likely that we will be wanting to update automated driving systems for many reasons. Sometimes because we might have observed something we want to change, sometimes to improve it, and sometimes maybe a regulator will come and say, we want you to change the behavior. So we cannot say that this is a monolith that we cannot change. So we need to be really good at structuring our safety cases to make use of actual good predictors for safety. There are going to be uncertainties in understanding the scene at runtime. And that makes it hard to predict the actual outcome of the strategy that you had in mind when you designed the vehicle. And I want to mention this specifically because if we start saying that the vehicles should behave in a very particular way in a very particular situation, it might be that those uncertainties that will be present always in assessing the actual situation might lead to us to act in a way in a situation that is not the one that acting was intended to be executed at. That was a very weird sentence, but it essentially means that if you write a very, very specific line of code that says, in this very, very rare occasion, extremely rare, do this, then probably you're going to do exactly that in many other occasions when that situation is not present, simply because you thought that that situation was present. And this is called the base rate fallacy. It's essentially the same phenomena that says that if you have a huge database of DNA samples, you will always find a lot of people in it. Doesn't mean you find the one that you're actually looking for. I will come back to in some few slides ahead on why that is important. And then I also want to say that the runtime adaptation is something that I believe is very important in achieving safety, because we can address issues that are very difficult to predict at design time. And weather conditions is a good example of that. So if you, for example, want to know, under which conditions can I promise full availability of everything the system could possibly do under the best possible circumstances? It's going to be very hard to say that what level of what's called rain. There's a fancy word for rain. At which level will you start losing functionality? So if at design time start saying that you want to be able to say when exactly you should switch on off the whole availability, that becomes tricky. It can sometimes be better to allocate that to the vehicle itself and say, if you're not sure, then adapt your driving such that you can still meet the safety requirements. And it might mean that if you don't see as much as you think you want to see, you can slow down so that what you see corresponds to what level of readiness you need to plan your driving. And then it doesn't become so important to say at what level of rain do I have to stop driving. It becomes more relevant to say, how do I have to realize that I cannot see enough to drive regardless of the speed. And this relates a lot to avoiding getting into hazardous situations rather than to be able to handle them when you're in them. And that is probably the key towards safe automated driving. Avoid getting into the situations to start with. So why is it challenging to make efficient legislation? I will finish this with an example, but some main bullets. We talked about some of them. It is very, very appealing to make tests and say that you should live up to these, you should pass these tests, and then we will say that you're safe. But we cannot test safety at vehicle level. We just talked about that. So tests are hard to draw conclusions from. And again, we talked about the base rate fallacy of saying that in this situation you should do that, in this situation you should do that, is tricky. Not only because you might do those things in the wrong situation, but also because the strategy that you have implemented may be very, very robust in almost all the cases, but it has weaknesses in some few situations. And because you will, when you look at things that go wrong, you will only observe that thin slice. And then you have to understand that this has a huge effect on other parts of the driving that we didn't observe. Secondly, if you do scenario-based testing, you have to understand that for those scenarios to be relevant, they have to be reachable by the vehicle at hand. So if I say that I want to test that I can manage a situation when somebody jumps out from a hidden corner at a very high speed, the relevant question is perhaps, can the vehicle even get into that situation? Maybe it always slows down when it approaches a hidden corner, or maybe it never drives that close to an area where someone can jump out. And those are arguably very good strategies for avoiding hitting those people. Then it would be unfortunate if you're required to design for something else. Or at least the test will not necessarily say as much about the true performance. And it could even be so that a vehicle that refuses to do a test because it understands that it cannot safely drive here, that's actually an example of a safe behavior. That's what we want humans to do. Don't drive unless you think you can do it safely. And finally then, component testing out of context is insufficient. It's valuable, but if you do simulations, you're limited by the fidelity of your simulations environment and the imagination of the one who does the simulations. And if you think that you can find important components to look at, such as we can see pedestrians at a very far distance, yes, that might be important, but it's more relevant to ask, does the vehicle react accordingly? And if you do, then does it matter if you saw that person at that distance or not? Maybe you're assuming that a certain distance away, there are always people that could exist, and then the driving is correct even without the detection. So if we make too specific requirements, then people might design specifically for that, but we might miss the point that was intended when putting it there. I see I'm running out of time, so I will be brief here. This is an example from my own experience. It's about automated emergency braking, and this is a legislation that became valid for trucks in 2013. And it's 3 years after I started with standardization. And when I started, I was young and ambitious. I'm still ambitious, but I'm not young. So I read all the documents that the group had written, and one was about automated emergency braking, and I found a bug. It was, and that was on the plane to that meeting. And I brought it up, and they said, "Oh, I see." And it took about 15 minutes to explain it, and then it took another 15 minutes to correct that bug. But unfortunately, UNEC had already glanced at the draft of the standard and used that as input for writing the legislation, and the bug was still present there. So when much later at the certification situation, we realized that the same bug is present in the actual legislation, it becomes harder. And what the bug meant was that in the test scenario, the timing of the different interventions, you would warn first and then maybe have a pre-brake and then you will have a full brake. They were defined as a function of the coming modularity. So you can see I circle it here. It says that you can warn, but it cannot come later than 1.4 seconds before the start of the emergency braking phase. And the way it was formulated meant that in the linear test case, when you drive towards a target, everything works as intended. But if you have a cut-in, which I tried to illustrate with the green car in the example, so it decelerates a lot and then throws itself in front of the ego vehicle, well, then you will come to a situation where you might confidently be able to determine that you have to slam the brakes immediately, because otherwise you're going to hit this vehicle. But then the certification agency said, the technical services said that it's not allowed to brake at this point, because you first have to warn, and you cannot brake until 1.4 seconds after you warned. So in effect, the legislation, the interpretation of the legislation was that we should just slam into that vehicle, even though all the systems were very confident that we should act right now. And that is obviously not the intent of the legislator. This is a bug, but it was hard to foresee. It required some skill in the functional design and the imagination about what scenarios are relevant to understand that this can occur. And it took significantly much more time to convince technical services not to add a line of code that says, if this is fulfilled, then just don't do anything, which is, of course, not what anyone wanted. So why am I bringing this up? I think my former colleagues tell me that this has been fixed now, so it's not an issue in the present legislation, or at least not in the interpretation of it. But it means that when we write legislation, it becomes important at some point, and people will at some point say, if we're not following it, you might be cheating or wanting to get an easy way out, and you are not allowed to do that. And then it becomes very hard to argue that you're actually trying to do something which is very, very good. And you can also be wrong, of course. That was the last thing that I wanted to say after the summary. Sorry about that. So standardization is a good way to define best practices, and it helps us in applying them. They can be vague, so you cannot trust them to take you all the way. They need to be continuously revised and updated when technology advances, and you have to think when you apply them, so you know you're applying them to the right problem. Secondly, automated driving is not a widely adopted technology yet. It means that it's hard to standardize it. There is no blueprint. We might think differently in 10 years than we are today. Safety is very challenging to prove for the reasons that I said, and because humans are really, really good, and therefore it's difficult to show that you're better or at least as good as them. And traffic safety is not mainly about managing critical situations. It's about avoiding them. Regulations are important. If it sounded in the previous example as if I wasn't saying that, that was not the intent. They're there to protect the society, and it contributes to building trust between manufacturers and society. They just happen to be difficult to formulate with respect to ensuring safe automated driving, because the complexity is so large that any simple rule might not do what it's intended to do, and complex rules are hard to analyze because they're complex. Humbleness is probably what can bring us forward here. Thank you for listening. It says questions, but I'm not saying that, because I think I used the 5 minutes for questions as well.
Yeah. Thank you very much, Fredrik. I don't see any questions in the chat yet, but don't hesitate to write questions on this presentation, even if we move on, because we have some time in the end, hopefully, that we can bring Fredrik and the questions back to answer. So I just have one short or question or comment maybe. I like your example there with the legislation, and I guess your message there is for a system like an ADS, it's easy that too detailed regulation would exclude good solutions, perhaps, that
Yes.
are not exactly the ones the legislator had in mind when they wrote it.
I haven't been able to come up with a good example of a legislation that sounds good, but that misses the target and requires you to make a worse system. But I'm using this to show that it is very complex, and you always have the risk of people designing towards the requirements rather than to the intent of the requirements. And I think that is the main challenge. If we put down easy rules and people that are making these systems make sure to fulfill them, and it's actually not that difficult to kind of pass the driver's license test if we were given the same task as a human. The devil is all in the details of the tails of all those distributions. So you might misdirect the effort. So legislators might think that we are going to make good systems. Public may trust them, and OEMs may think that they are delivering accordingly. And then after some time, you find out that it was a big mismatch, and we don't want that, right? We want to avoid getting there.
Yeah. Okay, thank you again. Please continue writing questions in the chat, and we will take them after all the presentations. But now we have to move on, I think, if we are going to follow the schedule. Right, Mario? You look concerned.
Correct.
Okay. I will try to share again then. Can you see my screen now? Okay.
Yes.
Great. Then I will talk a little bit about standards in the context of the ROADVIEW project. So there are two aspects here. One is that a project such as ROADVIEW can make use of standards to help us in our work. And one is that we can perhaps, hopefully, contribute to future standardization. And Isabel and Michael will talk about the last subject, and I will talk a little bit about how we can make use of relevant standards to help us in the project. See if I can switch. So in case you don't know ROADVIEW, the one sentence explanation here is the project works with improvements in perception and decision making for ADS or ADAS functions under harsh weather conditions, in particular rain, fog, snow, and other phenomena that can be a result of that, like water on the road or low friction and so on. An important aspect of that is also that you need to be able to test such improvements and test all the systems. So an important part of the project is that we use test facilities for rain and fog, and that we use simulation for all of these weather conditions, and also some open road tests for demonstrators. So there's different partners involved here, different facilities, different test environments, and we need to organize this somehow. So we use basically a test methodology that means we define a number of use cases. And in our case, adjusting speed to a vehicle ahead can be a simple use case. It means that we need to have sensors that can detect the vehicle ahead and distance and so on, and know the braking distance. So there's a number of challenges involved that can be differ if we have heavy rain or fog or snow conditions. Those conditions are contained in the operational design domain specification, where we have a definition of relevant weather ranges, like different amounts of rain, different thickness of fog, and so on. Then we defined some test scenarios based on combining the use cases and the ODD, and define a test suite in some suitable format that can be used in the test environments, and then run and evaluate the tests. So in this whole process, we can make use of standards in almost all of the steps actually. So first of all, we align our terminology using standards that are accepted widely in industry and research. We can use standards to define safety requirements or elicit safety requirements, the ones Fredrik talked about mainly. We can use it to describe the environment parameters, the ODD definition. We can use it to describe test scenarios and the test cases in some kind of interoperable format. The vehicle communication and the test execution and evaluation as well. So we have looked at what kind of standards are relevant specifically for this project, and we have a set of standards that we are working with, either have already used or will try to implement during the project. I will go through that, and it will be quite quick and many standard numbers, but you will have the presentation later posted if you want to go back and check anything. So for the general terms, I think Fredrik mentioned this as well, ISO 22736, which is based on SAE J3016, has existed for about 10 years, but evolved during that time. It defines basic terms for driving automation systems like ADS, ODD, and so on. And there's a newer one which is also relevant for this project, since we work with scenario-based testing. So, which means we define certain test scenarios which we use, and that is ISO 34501. So it has terms for scenarios, scenario-based testing. So based on that, we have built up a project glossary. So we are trying to use the same terms over all the organizations. So that's a way standards have helped us in that area. Then we have standards for safety. The most known road vehicle safety standards is probably 26262, which Fredrik mentioned as well. But for this project, we have ISO 21448, which is called safety for the intended functionality, which we think is the most relevant because it explicitly has insufficient sensor performance for different environmental conditions in its scope, and that's an important part of the methodology there. And of course, TS 5083 when it comes out. So we're awaiting that eagerly, Fredrik. Yeah. So for environmental conditions, there's also a standard, ISO 34503, which presents a taxonomy for operational design domain and some suggested ranges and metrics. We have used that. We have also, in some cases, extended it a bit with more specific ranges and types. There's also a format on its way, but it's not released yet. ASAM is working on a format called OpenODD, which we hope will be useful in the future. So for scenario-based testing, I think you may see that there is sort of a range of standards here, 3450X and 502 and 4. Specifically, they talk about 502 is the framework for scenario-based safety evaluation, and 504 is for categorizing scenarios. So we have at least been inspired by that when we defined our use cases and scenarios. Then for test scenario formats, we have standards from ASAM, Open Scenario and Open Drive. I won't mention that too much because Michael will talk about that later. But it's machine readable formats for describing scenarios and supported by many test tools and the simulation tools. Then we have standards for vehicle communication, which Isabel will talk about, and defined by ETSI, not ISO. So there's different standards for information between infrastructure and vehicles, and between vehicles and vehicles for different purposes. Then we have test execution and test evaluation. We haven't looked into that as much, but we have the open simulation interface from ASAM, which is interesting, and also an upcoming standard which is about test evaluation in the same series as several of the others. It's 34505. So we're monitoring that and perhaps can even contribute. We will see in the future. So lots of standards in different areas. So we have safety standards, we have testing standards, we have V2X standards, and so on. So it's useful for many purposes, and they help us align and use widely accepted methods and formats. And we have some project members active in standardization groups, which can give input based on the project results to future standardization. That's a quick run through of all the standards that we are currently working with, at least. Please tell us if we have missed something important.
I think, Fredrik, there are 2 questions in the chat.
They are in the chat instead.
Yeah, one is from Martin, and the other one from Sjoberg. Forgive me if I pronounce your name not correctly. And perhaps we can address those.
Yeah, we can start with one. Martins, do you see or have you seen difficulties in coming up with balanced requirements in a standard when they may reflect compromises that are also related to business concerns? I think that might be related to Fredrik's presentation rather than mine, but maybe we can take that one now.
Okay. The short answer is no. I have not seen that, but I guess the construct is such that it cannot be excluded, right? So I think as international expert or national experts in that international forum, it's good that we have a wide range of affiliations to make sure that that balance is done fairly and good. And when I didn't say that, but when I'm the Swedish expert in writing TS 5083, I'm actually appointed from Chalmers, and more specifically the Traffic Safety Research Competence Centre named SAFER. And I think it's good that such institutions engage in standardization's creation, specifically to make sure that these concerns are mitigated. Does that answer your question, Martin? Or maybe you cannot speak.
No, he cannot. He can write in the chat. I think we have a long question from Katrin. We will take that at the end of the webinar. I have 2 very quick questions about my presentation. One is there an overview of weather facilities which conform to ISO 34503? I don't think so, not to my knowledge. It's quite a new standard, so I don't think we have that yet. Maybe Michael, you know more since you are involved in the test facility? No. And another question, what is the series ISO 3450X called? I don't know if it has a name, but usually called scenario-based testing or something like that. But it's also the ODD taxonomy is also part of that series. Is there a draft of ISO 34505 already? Only for members of the standardization committee. So not the public draft that I know of. And I don't know when it will be released because I'm not in that particular standardization group myself. Okay, I think we will have to move on. There are more questions, but we will take them at the end instead. I will keep them, don't worry. So the next presentation is Isabel Morvan. He will talk about ETSI standards. Isabel is with Canon Research Center in France.
Yes.
Please go ahead.
So I will talk about cooperative ITS on ROADVIEW, what is the standardization environment, and then going to initial contribution towards those standardization and what will be the next steps for the ROADVIEW project. So first, as it was previously introduced by Frederic, ROADVIEW addresses the weather-related challenges for connected and automated vehicles. And what we plan to do in ROADVIEW is to use cooperative ITS services between vehicles and an infrastructure-based system to improve the perception of the vehicle and to provide some inputs to its decision-making system based on the weather conditions. So to have, we will use V2X communication between vehicles and with the infrastructure system. So to talk a common language, it's where we need some standardization to provide some interoperability between the various providers of CITS stations. So for that, in Europe, ETSI, European Telecommunication Standard Institute, is a standardization body that works on these standards. So the European radio regulation, according to the revised ITS directive, allocates some 50 megahertz of spectrum in the 5.9 gigahertz band for the road ITS application across all the EU member states. And it is a radio access technology neutral from the regulation point of view. So first we have the ETSI, so the ITS Technical Committee is in charge of developing a set of standards. So as for ISO, there is some technical report or technical specifications. It's mainly a contribution-driven process from the ETSI members, or sometimes through some specialist task force or test task force to speed up the work. So in ROADVIEW project, we have both Canon Research Center France and VTT Research Center in Finland that are members of ETSI. And so we are able to contribute based on the ROADVIEW project innovation or experimentation results. We can contribute to those standards. Especially, we plan to contribute more. Technical committee has several working groups. We are more focusing on the working group 1, which is developing some facilities layer message we will see after in this presentation. To have a common understanding of the standard developed by ETSI, there is also some organizations that are developing some system profiles. And first, there is the car-to-car communication consortium that is more for the vehicle side. We have also C-Roads platform, which is a joint initiative between EU member states or roads operators. So it's more for the infrastructure system side. And they focus also on checking the cross-border interoperability aspect. And last, we have a 5G Automotive Association that is a cross-industry organization that is more promoting the usage of cellular V2X as its name indicates. On the other side of the Atlantic, we also have SAE that is defining some similar standard than ETSI for the applications that use V2X communication system. So my next slide is about to provide some timeline of what is called the ITS release. And so the first ITS release version was more about awareness driving, means that the connected vehicles can share their current position or speed to the other connected vehicles or the connected infrastructure system. And now ETSI is working hardly to a set of technical specifications are now being published regarding ITS release 2. And one important part for us is the sensing driving. It means that the vehicles can, or the infrastructure can also share the sensor data they have. To give you some timeline about such a standard, so the collective perception service, there were first a technical report for pre-standardization study released in 2019, and the technical specifications were released last year. And now this year, the implementations are started, and there is a test task force to provide the conformance test specifications And there is some plan to have in the second half of this year some interoperability test sessions. Then based on this work, probably there will be some correction of the technical specifications, and then the implementers can start to deploy products using collective perception service. So in ROADView, we will see after we plan to use this collective perception service. And also we will have a look at the future of ITS release 3 or more, that is more about cooperative driving. So now I will just show the 3 CITS service we plan to use in ROADView. So the first one is the collective perception standards that was released last year. So in ROADView, we plan especially to have an infrastructure-based system with some roadside camera or roadside LiDAR that will improve the perception of the vehicles driving near this system. And especially one interest of this standard is that you can non-connected vehicles or not connected road users, such as the vulnerable road users, can now be integrated inside the V2X messaging. And one interest in ROADView to have such infrastructure system is that the cameras or LiDAR will be installed on a higher position, and maybe in case of bad weather, there will be more robust, less affected by the rain or the snow splash that the vehicle will have on the road. Next service we plan to test. And so for this one is we have a look at SAE, because currently HCITS doesn't have similar service. So we call it a road weather service, is to have a continuous share of the road weather conditions. So in ROADView, several of the partners will provide some weather estimations. So from the vehicle side, we will have some road slippeliness estimation, such provided by FGI in Finland. And the VTT will also provide some visibility estimators. And using also the roadside camera, we can have some weather classification, such as rain, fog, snow, or clear weather that will be detected from the technology of CEREMA. So all this information will be shared between the V2X vehicles or infrastructure system using a road weather message that is adapted from the SAE standard. So far, at CITS, regarding the weather information, there is possibility to generate some warning message through the DNAM when there is some harsh weather conditions. But in ROADView, we want to experiment another service having a continuous weather transmission. Last service we plan to implement is about it's more for the decision-making system. It is based on a maneuver coordination service. So this standard is not yet public. It's at the drafting stage, but there is some personalization study report that should be released quite soon. And so inside ROADView, so this standard is used between vehicles, automated vehicles, to share their intention. So the vehicle is driving, and he transmits what the trajectory he wants to follow. And inside the ROADView project, we will use the previous weather message to provide some weather-aware advice using these services. So regarding the ROADView project contribution to the standardization, so we had first an action from Eren with the coordinator of this project from Abstadt University, which did a presentation to explain the adverse weather challenges for automated driving and how ROADView will tackle those challenges. So this was done to the car-to-car communication consortium end of last year. And second, we have also some first contribution to ETSI. So from COF and VTT as a joint contribution more linked to the maneuver coordination scenario, and to share some use case. Especially, we promote the use case about driving on a slippery road, and we propose some message formats. So this was done also end of last year. So last, it's what will be the next steps regarding the standardization for ROADVIEW. So we plan to, so ROADVIEW is a technology readiness level 6 or 7. So we plan to have some real experimentation on the road with harsh weather conditions. So next winter, it's planned to go to Lapland area. And we plan to use to evaluate the 3 services I have mentioned before, especially the road weather services, as this one is not yet specified by CCAM. We could also share the result of our experimentation and to see the benefits of such service. Regarding the collective perception service, we will especially focus on the quality of the information in case of harsh weather condition, because if the sensors are outside of their ODD, the quality of the information should be questionable by the receiver side. And the last part, we will also evaluate using the maneuver coordination service, we will evaluate some infrastructure-based assisted maneuver, such as executing a minimum risk maneuver so that the automated vehicle can stop on the hard shoulder of the road. So this is the content of this presentation, to share what will be the V2X service we plan to use and the link we will have towards the HC ITS standardization.
Thank you, Isabel. I have 2 questions in the chat, so we can take them now, I think. So the first one is, are you planning on using LiDARs for road weather estimation, or will it just be camera-based?
So we will have 3 types of, for the roadside weather estimation, it will be camera-based. From the onboard vehicle, there will be more for the slipperiness estimation. So they plan to use camera, LiDAR. For the visibility range estimation, it will be more based on LiDAR.
Good, thanks. And also another question is, what technology will you use, DRSC or V2X?
So during the experiment demonstration, we will use, in fact, the public network, cellular network connectivity, because we are developing. Sorry, I have no more light.
It's okay.
We plan to use a cellular network because we are doing some new messaging experimentation, and so our scope here, it's the working group 1 of HC. It's more. It's between the application layer and it's the content of the V2X message and so on. It's not about the radio access technology itself.
Okay.
Because in ROADVIEW, I mentioned about the tests in Lapland, but there are also tests scheduled in Turkey and in Germany. So we have to go to a lot of.
Yeah. Oh, yes. Last one just popped up. Is V2V via 5.9 gigahertz still viable compared to cellular tech such as 5G or 6G?
So I think the organizations I've mentioned, especially car-to-car communication consortiums, more using direct communication range, and other 5G AA more promoting use of cellular V2X. They are now, promoting some technologies and the use of the cellular V2X in the band.
I think we will move on, continue to write questions, but I think we will move on to the next presentation. And if anyone have more questions, we will take them after. But for now, I want to introduce Michael Drexler, which will talk about standardization of AV testing.
Thank you, Fredrik. So we'll share my screen. So I hope you can already see it.
Yes.
So hello, everybody. Thank you very much, Fredrik, for the introduction, for the presentation. So as we already saw in the very first presentation from Fredrik, you already show us the importance of testing, of simulation, and supporting the whole developing of AV, the automated driving vehicles. And also Fredrik already showed from the ROADVIEW perspective how we intend not only to develop the algorithms to work or to drive under harsh weather conditions, but we also need to improve the test facilities or improve the test environments in order to integrate these harsh weather conditions that nowadays are usually not available inside the test conditions. So then basically I'll be presenting now much more from the perspective of the testing part. And when we talk about testing, usually the main limitation that we have is the interoperability between the different test platforms, between the different test simulators. And ASM do a really good work on it, trying to define how we can have like a standard data or standard files, a standard messages to exchange this data between the simulators. So then basically I will first briefly present you the open access standards from ASM, briefly overview so that we understand what we are talking about, also how ROADVIEW intend to conduct the tests, and then how we will be applying the open access inside our project. So talking about the OpenX, the Association for Standardization of Automation and Measuring Systems, so ASM, work in different standards, but between the standards that they have, or among the standards that they have, they also have the standards specific for simulation purposes. So we can see OpenDrive that describe map, Open Scenario that describes moving scenarios, so everything that is moving inside this map. Then we have the open simulation interface that basically describe the messages that are being exchanged between simulators, for example, between real entities and the simulator. We have open CRG that describes the relief of the ground, open label that describe the labeling of the images, for example, or of the data that is being collected, and open ODD that is being developed now to describe the ODD of the automated driving vehicles. So talking about OpenDrive, I will just focus more on the three main standards that we'll be using inside the project. So OpenDrive is XML data format that basically describe the whole map. So it has it uses a function, a continuous function, to describe the road, the middle of the road, and then also we have the positioning and different coordinate systems, including the road coordinate system and the global coordinate system. And on it we can also add the lanes, signals, and objects around, like buildings, parking space, and also the controller of the traffic lights, so we can set the traffic lights to red, green, and so on. And also all the junctions are a combination of roads basically, and they are saved as a junction or a group of junctions. If we go to open scenario, then there's also an XML data format, and it describes the entities that will apply any kind of movement inside the scenario that we are driving. We have some conditions like collision, initial point, the triggers, the speed of our traffic participant. We can have private actions that describe a movement or of an action of a specific entity. And we also have global actions that for us are important that describe, for example, the weather conditions or the traffic. And we can even have like user-defined actions that add some specific movement that were defined by the user. And when we talk about open simulation interface, basically we have the different simulators or different entities that run in different places in different computers, for example, and then we want to exchange this data in real time or in runtime, and then we use open simulation interface that is basically a message using protobuf, which describe the ground truths, describe the sensors, so we can also exchange raw data from sensors using such kind of messages, and it's really is being really useful for us, not only for this kind of application, but I will also show that we have been using it for data sets, for example, because it's open source, it's open access, so everybody can read, can have this definition of messages, and everybody can basically speak the same language when we are talking about the message that's being exchanged between the partners. So the benefits, the good points about the open access standards is that they are platform independent. So basically we can use it in any kind of platform, talking about different simulators, about different operational system, different languages. They bring us the definition of the data. They are specific for the automotive area. And they are being used for both from industry and from research. And they are also readable. So all these XML files or the protobuf are readable. You can simply open them and understand how it works. So then coming to the ROADVIEW test system. So basically in the very left side, so this side we have the host computer. So basically here we have all our simulation, as an example here, Carla, in which we have the models, the sensor models, camera, radar, LiDAR model that are being developed inside the project. And the noise models. These noise models we add then rain, snow, so all the weather conditions on top of the sensor models. Also our digital twin, the description of the scenarios that will be conducted inside this simulation. Then we have a simulation of the real hardware, for example, using a directed injection model like this one shown at the right side, that basically FPGA that converts data that comes from a computer in a raw data that looks similar to data that comes from a real camera, so that we can inject this data finally in our ECU or controller unit that will be on the test, in which we have all the algorithms developed inside ROADVIEW. Furthermore, we can also stimulate radar or LiDAR. So basically we are developing completely new method for simulating LiDAR over the air. So basically we are able to read the laser from the LiDAR, manipulate it using the simulation and send it back, so that the LiDAR is basically seeing what is inside the simulation while we are still using the real hardware from the sensor. And then finally, once we have all the processing of the data, all the decision making, we send this data back to our simulation, and our vehicle dynamics model is being driven inside the simulation. So then how we are applying the open act and all this this tool or this chain, basically, if we look to the digital twin, so the digital twin was developed, for example, in Charisma test facility using scanning, imaging scanning and total station positioning. So basically we have a digital twin that have a precision of millimeters, what is really good for this kind of development. After was the whole digital twin is developed inside Roadrunner using this point cloud that we have. And from these, then we can export an OpenDrive file. So that's basically the description of the map that we have, and also an Unreal Engine or an Onion Engine mesh, depending on the simulation that we are using. Yeah, and this, since we have like this open facility, we can also have the possibility to change the OpenDrive file and have different scenarios to be driven. Talking about the scenario description, we start from the use cases, as Frederick was explaining before. So as for example, here was VRU. Interacting with VRU. Unfortunately, my video is not playing for some reason, but basically there is a pedestrian there in the front, and this car should react to this VRU braking. Then we have the description of the scenarios in which we will be adding, for example, that is a rural scenario, that it's a sunny, so all the weather conditions, and also we can change, for example, the VRU that's being interacting with the vehicle. And then finally, we have some test case specific variables as a velocity, initial position, triggering of this maneuver, visibility, etc. So and then how we are implementing it. So from the road runner, we can also define the basic scenario, so as a test case, and we have the description of our test cases. This both then are, so basically from Roadrunner, then it generate a first open scenario, and this open scenario then is post-processed with a Python script, so that in the very end, then we have one open scenario file for each one of the test cases that we want to conduct. What we accelerate a lot for our testing process, because we can just then keep running different open scenarios. And when we talk about OSI, so first we'll be implementing as much as possible open simulation interface to do the exchange of data, for example, from the simulator and the stimulators, or from our driver vehicle dynamics model to the simulation. But also we have generated a data set from our test track in which we have validated rain condition. So basically we mount rain facility in which we can generate different intensities of rain, and we can control, we can measure it so that we can reproduce it when necessary. We have collected all this data, and all this data is now available as open simulation interface. And since it's a protobuf message, it can be then post-processed with different programming languages, MATLAB, Python, C++, and so on. And yeah, and the exchange of data, as I said before. So basically, the data that we have collected include like rotating LiDAR, MEMS LiDAR, radar data, and also RGB cameras and thermal cameras. So on the next steps now are basically this integration of the open simulation interface with the Carla API, so that we can directly get this open simulation data from Carla, and the full integration of the models and stimulators and the X in the loop system, and then we will use what we have learned from it to bring back to ASM and also update or improve the standards that are already being used. Yep. And that's it from my side, Fredrik. Thank you very much.
Thank you very much, Michael. It's good. I think now I will scroll back and I'll take the questions that we missed from the beginning. And in the meantime, you can write questions if you have to Michael. So the first one I see we missed was to Fredrik. I think I will try to ask it. Maybe the context is lost now, but you mentioned you have a background in estimation theory that made you see your help in one aspect. And do you have some words about that?
Yes. So it came into the presentation in two ways. One was in the interpretation of what absence of unreasonable risk means. And it's a linguistic thing. When you read it, what does it mean to have absence of unreasonable risk? Well, to me, it meant that there is some quantity here. There is risk, and it has to be reasonably low. So unreasonable becomes not. And it's the opposite of reasonable, and that means that it should be low. So that was one thing in interpreting it, rather than to get focused on what maybe someone coming from legislation would say, or functional safety, as we talked about it before, automated driving, when traffic safety came in, would say, well, this is unreasonable, it's foreseeable. But secondly, it helps me in my analysis of how we can prove that these systems are safe, simply by acknowledging that it is an estimation task to say that certain behaviors occur rare enough, and that the combination of components leads to things that can be predicted to occur even less rare or less frequently. And then you need to resort at fundamental estimation theory and statistics sometimes to be able to say that this is a verification and validation method that can work, and this is one that simply cannot work. And the example is, for example, if you drive, let's say 10,000 hours and you don't see any accidents, what does that really tell you? Well, you can have what is sometimes referred to as a Bayesian prior on engineering rigor that says that I am usually good and I can validate that with less data than if I have a totally blank prior. But you should also take into aspect that it means very little not to have seen something like that if you're talking about safety events that may happen on orders of magnitudes larger, once per 10 million hours or something like that.
Exactly. Yeah, that's good. Thank you for your answer.
You're welcome.
And for remembering what it was about. We had a question about OS 22736 and cybersecurity, but I think it was answered in the chat already.
Yes, there was an unfortunate absence of a comma.
Yeah,
so it's actually two statements that should not be read together.
And then I have a question. Maybe Aaron can help here. I hope you're still online. But the question is: do you have data sets of filmed real road driving labeled with relevant categories as defined in the standards? And are there ready-made AI models that can be used to find scenarios and attributes and categories you defined in the standards?
Yeah, we have a data set that is actually generated by THI people like Michael, but we are not at that level where the labels are following the standards and so on. I think if I understood correctly, that also goes to the annotation, standards in annotation, because everyone is using a different set of labeling and so on. We are not there yet, and I don't think at this level we will define any new standard. We'll basically follow the state of the art.
Great, thanks. Then we have a question to Fredrik. I don't know which one, but I think Fredrik Samblom. Do you think that harsh weather conditions as addressed in ROADVIEW are sufficiently taken into account in current standards, or are there gaps?
That is an excellent question that unfortunately doesn't have a short answer that also captures the complexity of the question. There are very many different approaches to what it means to be able to cope with bad weather. And to try to structure it, I think how you interpret that comes down to how you approach robustness. Do you see it as a design time property that you can say under which conditions are you going to be able to operate fully? And then you have a binary line that says if I'm outside this, then I cannot operate. Or if you see it that you're going to adapt continuously to a lot of variations. So at design time, you take the capability to adopt to that into aspect, but you leave the actual determination to the vehicle at runtime. So the difference here would be to say, if you have a vehicle, and let's for simplicity make up that you want to drive inside the lanes at 70 kph, and then you say under which conditions can this be done, and you start writing down all the specifications. So you get a very strict box and say inside this box I can always do this, but if I think that I'm outside I have to turn off. I cannot drive at 50, not at 30. I cannot do it if I have double solid lines, or it's like on or off. Then you need to do a lot of testing to ensure robustness of those decisions to weather. At the other hand, you could also design a system to say, what can I see? Can I see far? Can I see wide? Do I see things at the appropriate distances? And if you don't, then adopt the speed. And then maybe the question isn't to drive at 70 inside the lanes. It might be to take yourself forward and drive at a speed such that you can respond to the things you see. And then you have different requirements on how to treat weather. Now it becomes important to see that you can correctly assess your capability to adapt to weather and other conditions. So both of these methods, and they are valid in different situations. And I'm not saying which one is preferred. I'm saying consider both. And this one has properties that some may not see always. I like this one. But you need to react correct to weather in either cases. And I think that, sorry, this became a longer answer than I wanted, but it often comes up whether can this work if it's too hard rain is, for example, a very good question. I think we need to cope with that efficiently. We have to stop saying, can it work when it's raining or not? We have to start saying, how can I adopt so that I don't get outside my operational design domain?
Yeah.
That's the short answer. The short summary to a long answer.
Yeah, thanks. And I agree with you completely there.
I'm glad to hear.
Yeah, question to Isabel. Are you planning to use any weather forecast data for the RVS?
So in the road weather message service we will develop, we can also include some weather data coming from a weather station installed from the road. But during demonstration, we focus on the weather estimation provided by the ROADVIEW modules. But from the standardization perspective on the message format service, it would be possible.
Yeah, okay, so you can integrate that as well. Thanks. And then we have a question for Michael. How good is the performance of the sensors simulators? How was the validation performed?
It is a really good question. So basically, the architecture that I show you is a plan that need to be implemented into the end of the project. And one of the tasks of the project is really validating. So basically, we are now in the phase that we are developing the models that will be integrated in this hardware in the loop. And from now on, we start integrating, putting everything together. But this is an answer that I can only give in the middle of next year, in which you have finished this test can be validated in order to understand when and how we can use such kind of test environments to validate the automated driving vehicles functions.
Thanks. I'll move on to the next question then. It's for Isabel. Thanks for the overview. When ROADVIEW evaluates CPS scenarios, does it focus on communication aspect or perception and safety? Do you also evaluate simulation environment? And if yes, using also network simulation tools?
In the context of ROADVIEW, we are more focusing on the perception aspects, meaning for the V2X collective perception message, we are more evaluating the content of the message than the communication aspect. So we will not use a network simulation tool for this project.
Great, thanks. Michael, are you using open scenario for developing scenarios?
Yes, if the question is if you're using open scenarios to include the scenarios inside the environment, yes. But if the question is if we are using open scenario to create new scenarios that do not exist, not exactly, because the open scenario describe the scenario, but we need to plan how it will look like or how it will be defined beforehand.
Great. Another question for you, Michael. How does LiDAR simulator work for different LiDAR technologies? 905 nanometers, 1550, and so on.
Yeah, thank you for the question. So the LiDAR simulation is specific for each LiDAR. So basically, not every LiDAR can be stimulated. Rotating LiDARs, for example, cannot be stimulated. Only MEMS or tough LiDARs. And for each specific LiDAR, this system need to be built again, or need to be changed because the path, the position of the sense of the lasers, or the path that it follows is different. Due to that, each simulator is for one specific model of LiDAR.
Thanks. We have I think a final question here, a long one. I have movie files of hundreds of miles of driving in bad weather, different road types. How can I use these videos as a basis for training and validating AI models that can be used to develop systems for self-driving vehicles aligned with the new standard. Is it intended that all developers should use your openX simulators to develop and validate their systems? Maybe an open question, or the open standard simulation part, maybe Michael? And anyone can comment on how to use these videos.
I was asking if they are any labeled or anything, or just pure video.
Yeah.
But
Yes.
there's no follow-up. Nicholas,
Yeah.
if you're around, maybe you can comment on that, or it's unlabeled for
yeah.
now.
For now, I want to label them according to the standard.
But
I
if
guess
it's unlabeled, I don't think there is any way to train in a supervised manner. So maybe we can think about how to follow unsupervised, which might be a bit tricky. Yeah, but labeling based on some standards is an issue. So where are those standards for the labeling? Because I am not aware of any.
No, I don't know about the open label standard. Maybe Michael, you have some.
Yeah, this I would say the only standard that I know for labeling is the open label. Quite new, but it basically described the labeling process, or how to put the labels and images in the proper way so that they can be always exit. Maybe it's something that you could think about how to use.
Yeah.
Yeah, but there is we also need standard about labeling itself. Like, so when you see a car, there's a passenger car, there is a truck. Do you think everything should be labeled under the class car or vehicle, or should we distinguish truck from a passenger vehicle, or a van from a passenger vehicle? So there must be a kind of ontology about those labels, and based on the task, people should follow a different granularity in this hierarchy or this taxonomy. To my best knowledge, there is no such a thing. But in ROADVIEW, I can definitely say that we have not promised anything along these lines. So it's someone has to really dedicate time and research on this subject. It's not a huge amount of work, I will say, but someone has to really go through the literature, find out those differences, and then create a kind of common ontology that covers most of them.
Yeah. I haven't seen that. I'm not sure if that will come out from the open label work, common ontology, or if it's just a framework.
It looks like a JSON format in which you have all the objects, but I don't know if they have like a maximum definition of the types. Most probably, also as in open simulation interface, they already have predefined types. So basically, if you already have predefined types, you should separate accordingly, right? If you have van, car, passenger car, and then you need to accordingly distribute them inside the different types available inside the standard.
Yeah.
I think that they already have something in this direction.
Yeah. So we advise you to take a look at the open label and what comes out of there, at least. Okay, I think
maybe
our
just
time is. Yeah.
If you have time regarding the last question, is all the developers should use our open simulators. So basically, the idea is that the simulators should come more and more with the OpenX standards, so that we can always integrate. So for OpenDrive and OpenScenario, OpenDrive is already well disseminated. OpenScenario is being integrated nowadays, and Open Simulation Interface is something that needs to be added in the future.
Yeah, good comment. It will help everyone if we align on those standards. So with that, I think we are out of time for this webinar.
I think that before everyone leaves, I'm going to post a link in the chat for you to provide feedback on the session. In case there is something that works well or did not work well, you can just let us know, and we're always looking for ways to improve our webinars and this series. So I just posted a link in the chat. If you have any feedback for us, just let us know. And thank you for participating.
Yeah, thank you. Do you have some last word, Aaron?
Really, appreciate all that. It was fantastic. Our speakers, thanks a lot for joining us, and also participants. I hope it was interactive, useful. I think it was so, because we got quite many questions. Let's see.
Yeah.
We're going to have the third webinar in some months, but we have not planned that yet. So
Yeah,
see you
but
next time.
check out the newsletter and you will see
Yes.
when the third webinar
LinkedIn,
comes
you
out.
can follow the LinkedIn, right?
Yep. Thanks for today. Thanks all our speakers and all who connected and listened to all of this 1.5 hour. So
Thank
bye-bye.
you for having us.
Thank you. Bye-bye.
Thank you very much. Bye.
Bye-bye.